Welcome to our video on the gas laws. In this video, we will be discussing three of the most important gas laws: Boyle's law, Charles' law, and Avogadro's law. These laws describe the behavior of gases under different conditions and are essential to understanding the properties of gases. A diagram of a gas molecule moving around in a container. Before we dive into the specifics of each law, let's first review some basic concepts about gases. Gases are made up of tiny particles called molecules, which are in constant motion. These molecules collide with each other and with the walls of their container, creating pressure. A diagram of gas molecules colliding with each other and with the walls of a container. The behavior of gases can be described using several variables, including pressure, volume, temperature, and the number of molecules present. These variables are related to each other through the gas laws, which we will explore in more detail in this video. A diagram of a container with a piston, showing how pressure, volume, and temperature are related. Now that we have a basic understanding of gases, let's begin by discussing Boyle's law. Boyle's law describes the relationship between the pressure and volume of a gas at a constant temperature. It states that as the pressure of a gas increases, its volume decreases, and vice versa. A graph showing the inverse relationship between pressure and volume in Boyle's law. This relationship can be expressed mathematically as P and V equals P2 V2, where P and V are the initial pressure and volume, and P2 and V2 are the final pressure and volume. A diagram showing the application of Boyle's law to a container with a piston. Let's consider an example to illustrate this law. Imagine a container with a piston that is initially at a volume of 1 liter and a pressure of 1 atmosphere. If we increase the pressure to 2 atmospheres while keeping the temperature constant, the volume of the gas will decrease to 0.5 liters, according to Boyle's law. A diagram showing the change in volume of the gas as the pressure is increased. This law is important in many applications, such as in the compression of gases for storage or transportation. It also helps us understand the behavior of gases in everyday situations, such as the deflation of a balloon when it is squeezed. A video clip of a balloon being squeezed and deflating. Now that we have a good understanding of Boyle's law, let's move on to the next gas law, Charles' law. Charles' law describes the relationship between the volume and temperature of a gas at a constant pressure. It states that as the temperature of a gas increases, its volume also increases, and vice versa. A graph showing the direct relationship between volume and temperature in Charles' law. This relationship can be expressed mathematically as V1/tone equals V2/T2, where V and tone are the initial volume and temperature, and V2 and T2 are the final volume and temperature. A diagram showing the application of Charles' law to a container with a fixed volume. Let's consider an example to illustrate this law. Imagine a container with a fixed volume of 1 liter and a temperature of 273 Kelvin 0 degrees Celsius. If we increase the temperature to 373 Kelvin 100 degrees Celsius while keeping the pressure constant, the volume of the gas will increase to 1.366 liters, according to Charles' law. A diagram showing the change in volume of the gas as the temperature is increased. This law is important in many applications, such as in the design of engines and refrigeration systems. It also helps us understand the behavior of gases in everyday situations, such as the expansion of a balloon when it is heated. A video clip of a balloon expanding when it is heated. Now that we have a good understanding of Charles' law, let's move on to the final gas law, Avogadro's law. Avogadro's law describes the relationship between the volume and number of molecules of a gas at a constant temperature and pressure. It states that equal volumes of gases at the same temperature and pressure contain the same number of molecules. A diagram showing the equal volumes of two different gases containing the same number of molecules. This relationship can be expressed mathematically as V1/none equals V2/N2, where V and none are the initial volume and number of molecules, and V2 and N2 are the final volume and number of molecules. A diagram showing the application of Avogadro's law to two containers with different volumes. Let's consider an example to illustrate this law. Imagine two containers, one with a volume of 1 liter and another with a volume of 2 liters, both containing the same number of molecules of a gas at a temperature of 273 Kelvin 0 degrees Celsius and a pressure of 1 atmosphere. According to Avogadro's law, the two containers will have the same number of molecules of gas. A diagram showing the equal number of molecules of gas in both containers. This law is important in many applications, such as in the calculation of the amount of gas needed for a chemical reaction. It also helps us understand the behavior of gases in everyday situations, such as the mixing of gases in the atmosphere. A video clip of the mixing of gases in the atmosphere. Now that we have covered all three gas laws, let's summarize what we have learned. In this video, we have discussed three of the most important gas laws: Boyle's law, Charles' law, and Avogadro's law. These laws describe the behavior of gases under different conditions and are essential to understanding the properties of gases. A summary of the three gas laws and their equations. Boyle's law describes the relationship between the pressure and volume of a gas at a constant temperature. Charles' law describes the relationship between the volume and temperature of a gas at a constant pressure. And Avogadro's law describes the relationship between the volume and number of molecules of a gas at a constant temperature and pressure. A summary of the applications of the gas laws. These laws have many applications in science and everyday life, such as in the compression of gases for storage or transportation, the design of engines and refrigeration systems, and the calculation of the amount of gas needed for a chemical reaction. A summary of the importance of understanding the gas laws. Understanding the gas laws is essential to understanding the behavior of gases and their properties. We hope that this video has helped you gain a better understanding of these important laws. A thank you message. Thank you for watching this video on the gas laws. If you have any questions or comments, please leave them below. Don't forget to subscribe to our channel for more educational videos like this one.